Okay, let's keep going with lesson 23. So again, I'm hoping that you've watched the videos that go along with this lesson so it gives you the background and the theory about it. So what we're talking about is correlation and least squared regression line. So we can see that things are correlated, means they have a relationship with one another, but you can't say that it's caused by that. So there's a lot of things that we can look to see that increase at the same time, but they might not be related. So again, let's talk about some easy stuff. So in the calculator, and I did this in the calculator help, but I'm going to repeat it right now. If you need to clear your list, you're going to go turn your calculator on. You're going to do second plus 4 enter. And that clears out your L1, L2, L3. Another important thing you need to do here is you need to do second catalog and scroll down to diagnostic on. Let me keep going down. So if I go down to here, and I'll see in a second, I'm going to hit enter and enter. And that turns on the functions that I need to get the slope, the y-intercept, the r, and the r squared. Okay. So for these kind of problems, you're going to use the calculator. And it's going to give you the linear regression line, the slope, the y-intercept, the r squared, which explains variation of y explained by x, but for this class you're not going to need it, and your correlation coefficient, which is r. So let's do one here. We're going to put it in. So let me bring up my calculator. So I'm going to go to stats, and I'm going to hit enter. In L1, I'm going to put my ages because that is my x variable. I'm going to do 5, 6, 4, 7, 8, 9, 5, 6, and 7. And if you go up, you see I made a mistake. So I need to go correct it. Because see here, if I go up, I put 64, and there's no way somebody in this age group of children is 64. So I'm going to do 6, and then I'm going to go down and do 4, and I got to put my data in again, and that actually shows you that even I can make mistakes putting stuff in the calculator. So as a rule of thumb, and what I even do when I'm putting in data in the real world examples, when I run analysis for people, is I go back and check my data. Okay, so I put all that in, and I'm going to go back up to the top. The next thing I need to do is where there's 7, I go to L2, I scroll over, and I put 50. Because in my data set, I see that I had a 7-year-old who weighed 50 pounds. And then I had a 5-year-old who weighed 63, a 6-year-old that weighed 52, a 4-year-old that weighed 49, a 7-year-old that weighed 61. So I'm going to put the weight that corresponds to each child's age. And I don't want to mess these up because these are 2 points of data that correspond to one child. So I'm going to go ahead and put them all in and then do 70 and then go down. Okay, so then I'm going to go to stat. I'm going to go over to calc. I don't even have to go to test. I'm not doing any test. I'm just going to calc. I'm going to hit 4 for LinReg, and it's going to come to the main screen and show LinReg, and I'm going to hit enter. Okay, so it gave me a bunch of information. So let me scroll down so you can see what it gave me, and you can compare it to if you're not using the calculator. All right, so first thing, linear regression, so it tells me what I ran. Y equals AX plus B. A in this case is the slope, B is the y-intercept. So it told me my slope was 3.80392159. It told me my y-intercept is where the line crosses the y-axis is 35.75490196. My r squared is 0.4591, and my r is 0.677602383. Okay, so It's going to ask me to find my least squared regression line. And all I did was plug in A and B. That's all I did. I got it from the calculator and I plugged it in. And then it says find the correlation coefficient. Don't use R2, just use R, and you get 0.6776. If you aren't seeing your R squared or your R, it's because you've got to do that diagnostic on I explained in the very beginning of this video. Okay, and then it says I want to find out the weight for a child who is 5 years old. So all I'm going to do is for here where I did my linear regression line, I'm just going to plug in 5 where the X is. And if I do that, I get 54.775 pounds. And one thing I did kind of gloss over I need to talk about is here. This correlation coefficient talks about how strong the relationship is between age and weight. So for here, it's a positive number, so I know it's a positive correlation. And it's between 0 and 1 that you look at these for. And this is kind of upper going towards 1. So I could say there's a moderate positive relationship between weights and ages for this group of children. I can't make this assumption for adults based on this material, and I can't make it for toddlers. It's only for this set of data. So I hope this kind of made sense to what we are doing. If you have questions, just let me know.